Today's lesson is on polynomials and their real-life applications. To begin, we need some formulas that we can use. Let's do perimeter. Perimeter is generally known as sum of all sides. So let's write that up there, and let's also use area. Area of a rectangle would be length times width. Area of a triangle would be 1/2 base times height. Okay, let's start there. Let's use that. Now with that in mind, let's draw us a triangle, or I'm sorry, a rectangle. And let's just make the assumption that the length here and here are the same. 3x squared plus 2. And let's say that this side and this side are equal, and let's make this x plus 3. Alright, well, what would the perimeter be? What we would do, sum of all sides, well, if these two sides are equivalent, we would multiply this by 2 and then add it to this multiplied by 2. And it would look like this. 2, 3x squared plus 2 plus 2 times x plus 3. Alright, why don't you solve this one out now that we know what we're doing. To give you a little hint, distribute this 2 to everything and then combine terms. Or distribute this 2 and this 2 and then combine terms. Pause the recorder now. Okay, when you finished, you should end up with this. When you multiply through, you get 6x squared plus 4 plus 2x plus 6. Well, 6x squared and 2x do not go together. Why? Because the 2 and the 1 are not the same. In order to combine terms, you have to have both the same variable and the same exponent. This has an x squared, this has an x to the 1 power, so they're not the same. However, this 4 and this 6 go together. Combine those. Okay, so if they don't go together, here's what we have to do. We just bring down what doesn't go together, and we combine what does. 4 and 6 make 10. So the perimeter of this right here is 6x squared plus 2x plus 10. Now, what would the area be for this rectangle? Well, using the formula, A is equal to length times width, or L times W, well, it would look like this. 3x squared plus 2 multiplied to x plus 3. Okay, do the math. Pause the recorder now. Alright, well, here's what you should have gotten. Multiplied, well, I would have written it this way first. 3x squared, parentheses, x plus 3, plus 2x plus 3. Now, where did I get the numbers? Well, you should remember 3x squared, plus 2, plus 2. And in these parentheses is this right here. And what we're doing is we're multiplying every monomial that is in this parentheses to every monomial in this parentheses. Now, once you distribute combined terms, you should have your answer. And your final answer would be, let's see here, 3x cubed plus 9x squared plus 2x plus 6. And that is the area of that rectangle. Now you may be asking yourself, let's see here, let's scroll down and take a look at another problem. Let's do this one real quick. Total length of a board is 5x plus 7. After cutting a piece 2x minus 3 long, what is the length of the remaining piece? Well, I always like to draw a picture. So even though my lines are not straight, you can visualize this being a piece of board. Okay, now what we do know is that the entire length from here to here is 5x plus 7. And the instructions say that we cut the board off right here, approximately, and this side was 2x minus 3 long. Now, if that's the case, I need to figure out that right there. Well, take a minute and see if you can figure out what the equation would be. Pause the recorder now. Okay, now let's check it out. Let's see. If we take the total and subtract the piece we cut off, it should give us the question mark. So your equation would look like this: 5x plus 7, I always put that in parentheses, minus the second one, 2x minus 3. And it should equal what I want. Now, you go ahead and solve that one. Pause the recorder now. Your final answer is, and notice, this parentheses is multiplied by a positive 1. So when we have nothing out in front, we assume that it's positive, and we can just drop the equation, or drop what's inside the parentheses without changing any signs. But notice here we have a negative. Now this negative is implying a negative 1, which means we'll multiply the negative 1 by anything inside the parentheses. Or actually all it does is just change the sign. So 2x to positive 2x, it changes to a negative 2x. And this negative changes the negative 3 to a positive 3. Now let's combine terms. What terms go together? Well, I know this 5x goes with this negative 2x because x to the 1, x to the 1. And I know that this plus 7 goes with the plus 3. So I have 5x minus 2x, which gives me 3x. And 7 plus 3 is 10. So there is the length of the board that is remaining. And that's my answer. Let's try another one here. What if you had, let's write this out. What is negative 6c plus 8g decreased by 6c plus 1g? Think about that. Write out the equation. Pause the recorder now. Okay. Let's see. What is this decreased by this? Decreased implies subtraction. I'm going to take this and I'm going to subtract this from it. So it would be negative 6c plus 8g, parentheses, minus 6c plus 1g. Okay. Take the time and solve this problem out. See what you come up with. Pause the recorder now. Okay. Again, this is no sign out here, so we assume we're going to add it or multiply by a positive 1, which doesn't change any of the problems inside or any of the terms inside. So let's just bring it down. But here the negative, there we assume there's a negative 1. I want to put it out there so you can see it. Negative 1. See? We can always put a 1 in front of the parentheses. When we multiply a positive 1, nothing changes. But when we multiply by a negative 1, it changes the signs. 6c is positive here, so it goes negative, negative 6c. And negative 1 times a positive 1g becomes a negative 1g. Now, combine terms. And let's see what terms go together. This one goes with this one. And this one goes with this one. So your final answer would be, let's see here, negative and negative, that's going to be a negative 12c plus 7g. And there's my final answer. Okay, there's enough examples for you to cut your teeth on. This is how we use polynomials in real applications.